Hey y'all, welcome back. I hope you're all well. Thanks for joining the channel again, and thanks for tuning in. I got a question on the comments section regarding the HK725, and it relates to an issue I'm also having with this HK725. A person posted that he's having problems with one or both channels dropping out when you're using the amplifier. And this one is no exception. It has the same experience. After I did all that work in the last video for this amplifier, I put this to work and I listened to it, and yeah, it did come up a few times where one channel would drop out and disappear, go quiet, and I have a good idea what's going on with that. Let's dig into this. There is on the output of the, let's turn this around. I can't really demonstrate it because it's something that's, intermittent and it's flaky and it happens once in a while, so it's hard to replicate. But on the output, just before the output of the preamplifier, there is a small relay, 24 volt relay. And the problem is the relay contacts are getting dirty or oxidized and providing a high resistance to the signal flow. So what I propose doing, instead of taking the relay out or cleaning it or any of that stuff, I'm going to replace the relay. I'm going to hunt down a suitable replacement. And we shouldn't be too hard to find. It's kind of an industry standard, the lead outs and the form factor and everything else with relays is pretty standardized. You have it's a 24 volt relay, double pole, double throw. We'll get into have a look at the schematic here, and I'll show you exactly what it does. But I'm just going to get the cover off here first, and then we'll have a look at it. All right, so here we go. We got the the top off, and this one here, this is the output of the amplifier, and this sends a signal back, and directly before the output there's this relay, and it looks like it's made by Fairchild. I don't know the F with the line above and the line below, and it has marked on the relay 221D024. which this part number might or might not be meaningful, so we'll look it up. The part number itself has an 024 at the end, which suggests it's a 24 volt relay. The 221 is probably the style, the D is probably the configuration, but this relay here is the culprit for what we're hearing with the dropouts. Now you can remove the cover of this relay and you can play around with the contacts. I really don't recommend that because this is quite a fragile device, and as soon as you start trying to clean contacts with abrasives or whatever, what you're actually doing is you're removing the coatings. But we'll see if we can find a suitable replacement. Let's go look at the schematic and see what it does. Alright, so here we got the schematic for the 725 up on the screen, and it shows the relay here. Here's the coil for the relay, and it's got diode protection, and then it's tied in with these sets of contacts here. This is your output, the left and right channel, and I believe when the coil is de-energized that this should be flowing through. That's what it looks like to me, because normally when you draw a schematic, you draw the switches and the relays in their de-energized position. But this little circuit here, this takes a tap off the secondary of the power transformer, and it goes through here, and it goes through this little time constant circuit. I'm sure this C609 is a 100 microfarad capacitor. I think this, by the time this charges up, and then turns this transistor on, turns the relay on. So that's probably what they're doing to create the 3 or 4 second delay on the turn on. But anyways, the purpose of this relay is to ground, see there's a ground here, is to ground the output when there's doing its initial turn on. And when you're doing initial turn on, you're going to get all kinds of bumps and thumps coming from your amplifiers. So you want to mute that. So what they do is they put the relay in there to shut off the signal for the first 3 seconds maybe. And then after the 3-second time's out, it turns the switch on and allows the signal to flow through and out to your amplifier. But that's what they're doing there with that. So the problem is you get high resistance contacts on these relay contacts, and instead of maybe 50 milliohms resistance, you might have several hundred ohms or maybe kilo ohms of a resistance through those contacts, and that's why the channel drops out. Here's a drawing of the printed circuit board. I believe this is from the top down looking. So here's our relay and here's our output. These two pads would be our signal coming in from the preamplifier, and these would be our common. These two contacts here would be our coil, because there is a diode across these two right here. Here's a diode 604, and then here's the two transistors that turn this on and off. This trace here is a ground trace, which would be shorting, the contacts would be shorting the signal to ground, and then these two contacts are the outputs. So let's see what we can do with getting this relay. So if you look in the parts list, it doesn't really help us. It's got relay 601, and this is the Harman Kardon part number. It's a muting relay, we know that. And then the 221D024 Almiron is a manufacturer, and that's that part number that's printed on top there. If we do Google search on this number, it doesn't pull up too much. This part number is probably, well, how old is the unit? It's made from the 80s, so this part number might be 40 years old and no longer in production. And it would be superseded and replaced by probably many different types of relays. So we're going to have to see what we can find that will fit and work and do the job for us. All right, so what I want to do first is I want to remove the relay, and that's going to involve removing the screws from the back. There's one screw here holding the board down to the base. So let me get these screws out, and we'll get that relay removed. All right, so we got the screws out. The board is free. I can remove the board, flip it over, and I can desolder the 8 pins for this relay. And be careful with these pins. My thing is not warm. Okay, I should be able to just pull it out now. There we go. I can see the contacts, and I can see there's gold on some of the surfaces, but it's also oxidized on the sides of the contacts. It's all black with oxidation. So this must be some kind of a silver gold alloy. And yeah, like I said, I don't recommend cleaning these because the contacts are so fragile on them. And if you start sticking paper or anything in between these contacts, you can end up bending them and doing more damage than good. But we'll see what we can get for replacement here. Let's put this back together. Let's go on the DigiKey website here. I'm going to use DigiKey because I do order a lot of parts through them, and I have set up an account, and they do free overnight shipping and all the good stuff like that. So I usually do my business with DigiKey, but there's other retailers out there you can do. So let's go search for a relay. Let's go electromechanical relays, and let's search for signal relays up to 2 amps and see what that brings us back. 6,600 relays to choose from. Okay, the quickest way usually to filter out all the hash is to just go by coil voltage. So I'm going to set the coil voltage here to 24 volts DC, right here, and that immediately drops everything down by 1/10. And let's see, we need through hole, so let's select through hole, and that drops it down to 261. And we are going to also want, what else do we want? We want the active ones. Okay. Actually, let's get rid of that. Let's search through it because they might have old stock in here. Now we need a double pull, double throw. DPDT 2 form C. I don't know what 2 form C is. 2 form D. Let's select that one. Double pull, double throw. And that pretty much selects all of them and eliminates all the other ones. What else can we look at here? We don't want latching or anything like that. We don't want diodes. We don't want it fully sealed. We don't want to jack the price up to several $100s. Gold contacts, we can select those after. And we have a relay type, general purpose. Can't see it on the screen there. General purpose RF or telecom. I think we might be sticking with the telecom ones. But this narrows it down to 150. So let's go through these 150 and let's have a look. See what kind of relays we have here. I don't know what the different forms are. Where is it? Form C and Form D. These are all Form C. I'm assuming these are Form Cs. Can continue looking down here. Let's see about Form D. If I can find one. Can't find one. Here, let's open this up. Yeah, they're all the same form. Let's filter out this form, contact form. Let's remove that. And let's go to, where was it again? Form D. Let's have a look at these. It's hard to say. Okay, let's eliminate that altogether. Let's look at this. Let's see what we have. Sort these according to price. 79 cents for a relay, that's good. But that's not what we need. See, these are power relays, so we don't want that. We want telecom, I think. So let's go over here. General purpose. Let's select telecom out of our list. And see, this brings us down to 73. This one here is not the right form. This might be a problem finding a relay that is similar. What we might have to do is dig into some data sheets and specify special. Yeah, these are not. These are all telecom. Let's take this one for example. Let's look at the data sheet for it. All right. Discontinued. Harman. Just trying to get a look at a pinout here of what they have. Okay, so coil, common, numbering closed, numbering open. Coil. Yeah, this won't work. We're going to have to get into this a little deeper. Okay, so let me put the camera on pause. I'm going to search through some databases here and see what I can find. All right, so it's a day or two later, and my relay has come in. You can see there's quite a difference in size. So I'll tell you what, actually I'll show you what the part number is in the relay I ordered. It is this one here. Where is it? My pen. This one here, this small number, is an AGQ 20024. And this is the DigiKey stock number. And it's a telecom relay. It's a 24 volt, and it has up to 2 amp contacts, but we don't use 2 amp contacts. So this is just one of hundreds of relays I could have selected from. So that is not a hard or fast rule on relays, but this is what I selected because of a number of things. It is a double pull, double throw. It's got wire leads through hole mounting. It's got silver palladium contacts. It's 24 volts, and it's a telecom relay. So as you can see, there's quite a bit of size difference. It's probably 1/6 the size of the original relay, and it'll perform just as good as the original, even if not better. Word on this other relay, if you go on eBay and look around, you'll see, if you Google this part number on this old relay, you'll see listings come up on eBay, and if you read carefully, it's probably a pull, so it's a used relay. You're not any better off buying their used relay than you are with your used relay. These relays aren't abused any, they're just used, but the problem is it's 40 years old. The contacts are starting to corrode, and I could actually, let me try zooming in, maybe you can see these contacts. They're pretty tiny. I'll take the lid off first. And like I said, I don't recommend, here let me zoom in, if I can keep this in frame. You gonna be able to focus on that? I hope so. Move that out of the way, get this background here. Maybe that will help. Okay, so I need a pointy device. The contacts are here. Actually, there's one set of contacts here, there's one set of contacts on top. And these two copper, well, they look like copper, but they're actually some kind of an alloy. As you see, if I lift up on the contact, it moves. But if you get actually a magnifying glass and look at those contacts in there, you'll see that they're all black. And let me see here if I can see that right now. Yes, they are black. And that is the problem with the dropouts, is that you get a black oxide coating on the contacts. These relays are starting to get 40 years old, and when you start using them, they're unreliable. So my plan is to replace it with a new one. What I'm going to need to do is I'm going to need to fix some wires here, because the pinout of this relay is not the same as the pinout of this relay. And as you can see, it doesn't even fit in the holes. It's not even close. So what I'm going to need to do is I'm going to need to attach a set of wires for the coil, maybe a set of wires for the normally open, normally closed contacts, and then the common. And then what I can do is I can just wire it into the board. But as you can see, that's quite a big difference. So what I'm going to do is I'm going to attach little short wires, probably about an inch long, maybe. Probably an inch is too long, probably about half an inch. I'm going to attach wires to these so that I can, when I put it back in the board, I can match it up to the board here. Now I got a choice. This board sits about 3/4 of an inch off the chassis, so I could mount the relay underneath, or I could mount it on top. Either way, it's going to be working. I'd rather, probably what I'm going to do is mount it on top, because what I plan on doing after I mount the relay is I'm going to get some silicone adhesive, and I'm going to use it to secure the relay to the board so that it's not flopping around by the wires. If I leave it dangling by the wires will break and just cause problems in the future. So I'm just going to mount that with some silicone, and that relay's done. So what I'm going to do now is I'm just going to, with these wires, I'm going to attach 8 short little wires to these 8 pins, and I'll probably heat shrink it so it looks nice, and then we'll get it mounted on the board. Put this away. So like I was saying, you'll probably find these relays on eBay. I doubt they'll be new old stock. Even if they are new old stock, they're still old, and the corrosion has taken its toll on these, and I wouldn't trust a new old stock relay that's going to be 40 years old to perform today. This thing probably had a lifespan maybe 30 years, and then the oxidation sets in, and then it starts to misbehave. So that's what we're doing. We're getting rid of this relay, put in a modern one, and we'll get another 30-40 years out of this. This relay's sealed, actually. There is no way to open it up, and there's no way for oxygen to get in. So this relay could last indefinitely. A little Panasonic relay, 24 volts. And like I said, another thing is this F on here is not Fairchild. This is Fujitsu. This relay is made by Fujitsu, and they still make relays today. Not the same model, not the same part number, but quite a bit different. They're all scaled down to this size now. This is the trend, right? This is your trend. This was the trend. All right, so let's. I'll get some wires soldered on, and I'll get back to you when that's done. Okay, so I'm back. I got the wires soldered on. It's not pretty, but it works. One thing I did is I took a 24 volt power supply and I attached it to the coil leads. And it was interesting to find out that the coil will only latch or turn on or energize in one direction. So that's why I put red for positive, black for negative, quite naturally. And then the other pins, I have the data sheet here, and to figure this out, so my common pins 3 and 6 are the blues. All right, so I gotta go blue as common. Now, normally open is the 4 and 5, which I put brown wires, so it's brown. The normally closed is 2 and 7, which I put yellow wires. And then of course the coil is positive, negative. So what I need to do is match that up with this. The common here is these two wires on the back, and that would be with regards to my blue. And normally open is these two here, and that would be my brown wires. And my normally closed would be these two, which would be the yellow. So and then the coil itself. Now I have to look at the schematic to determine which side. This relay has no diode installed in all across the coil. Sometimes they do, sometimes they don't. I ordered one without, So because there is a diode in the circuit, if I look here, let's get this out of the way. Pull this into view. You see this big diode here, D604? That is the coil diode. So we got one on the board already, and I didn't need to get one in the relay. I could have got one in the relay and I could have just removed this, but I decided not to. So now what I need to do is I need to match up my different wires with the different holes here on the board, and we'll get this mounted somehow. I was thinking maybe laying it down. Let's see, what could I do here? I could lay it down like something like that, secure it to the board, and then just attach the wires through the holes. I want to be careful. I don't want to get too much extra length in the wires, because anytime you have a long wire, you're going to pick up stray hum or other noise. So what I'll do is I'll go work through that, and we'll come back once I have this connected. Okay, so I just want to determine the polarity of what the relay is being supplied with these two pins here. I'm just going to put a voltmeter across it. Let's put a voltmeter across these, and I'm just going to switch the power on, if I can do this one-handed here. I'll switch the power on. I won't. Okay. So that's negative, positive. Okay, so positive goes this side. And let's see here. We got 35 volts, which is unacceptable. Why did it drop? Okay. 35 volts, and this side here is positive. Let's put a little positive here. Now, the reason it's 35 volts is because we have a 1K dropping resistor here, and they're depending on the coil resistance, and the 1K should drop it down to 24 volts for the coil. And what did I measure? I'll have to see, because the coil resistance for this coil relays, let's see what I measured here. 35 volts, just about 36 volts. I'm going to do the math on that. The coil resistance of this here is 2.5K, and then with the 1K, that would put it at 3.5K, but then it's a resistor divider network. Let me measure the coil resistance of this one, and then we'll know if we need to change that 1K resistor. What do we got here? One thing I don't want to do is pump too much voltage through the coil and burn it out. Yeah, we got 1.1K here. So we're going to have to change this resistor, I think. And I'll do the math and I'll figure it out to make sure that we're getting 24 volts on that relay. I saw on the spec sheet somewhere that not this sheet, it was in one of the specifications that it's don't want to go more than 120% over 24 volts. So that's what I'm going to target. I'm going to target 24 volts, and we're going to see how this works out. All right, so we're going to have some hard math here, so get your thinking caps on. I redrew the circuit. This is what was there existing. We had a coil resistance of 1.1K, a 1K resistor in series to drop the voltage for this coil. And I did some calculations. Overall, there's a 17 milliamp flow through this leg. When this transistor is turned on, we have a positive supply of 36.3 volts or so, 36 V3. But this transistor is going to drop that by about 0.6 volts. So it's roughly 36 volts, 35. We're not going to get too fussy over that. And I did the calculations through the 1K, through the 1.1K, and that leaves me with a voltage drop of 18.7 across this relay coil and a 17 volt drop across this resistor. Like I said, 17 milliamps total going through here. So this is what we're replacing it with. We have a 36 volt source, but our coil resistance has increased to 2.5K. Also, from the relay spec sheet, the normal operating current for this coil is 9.6 milliamps. So we're going to take that, we're going to use this value as our starting point. So what we want to do is, what is the resistance of this total resistance from here to here to get 9.6 milliamps on 36 volts? So it's a simple matter of R equals E over I. So we're going to have 36 divided by 0.0096 amps equals 3750. All right, but we already have 2.5K here, so we're going to minus 2504 for the coil resistance, and that leaves us with 1.2K. So this here equals 6 ohms, and that will give us a current drop of 9.6 milliamps through this. So I'll change that resistor to a 1.2K, and actually let's calculate what the voltage is across each of these. So E equals I times R. So let's do this. 0.0096 times 1246 equals, and we'll get 11, well, let's say 12 volts. Drop across here. Okay, and 2504 times 0.0096 equals 24 volts. Look at that. So yes, I'll take this 1K resistor out and I'll replace it with a 1.2K, and that should balance this circuit out perfectly. We'll get 24 volts across our relay coil, and we'll be right in the range of 9.6 milliamps when this circuit turns on. And everything should be good. Now, one thing I want to do is power for this resistor. They had like a 2-watt resistor here. It was a times 2 watt. So let's see what kind of wattage we're going to need for this resistor. 12 times 0.0096 equals, and we got about 115 milliwatts. So a 1/4 watt resistor will work. So we replace this with a 1/4 watt resistor, and or even a 1/2 watt resistor, whatever I have, and we'll make it 1200 ohms. Maybe I'll get one that's maybe closer to 1250, and we're good. We can put this relay in and it would work. All right, so I got it installed now, and I'm hitting the finish line here pretty soon. Just want to show you what it looks like. And I know it's not pretty, and I know I'm probably going to take some heat for the sloppy mounting. I probably could have, people were telling me better ways to do it. That's fine, you can go ahead and do that. I still have to mount this down to the board. I was thinking I could do it here in between all the wires. You have to be careful, these wires are very thin and you don't want to flex it too much to break any of them off, especially the pins that come out of the relay. They're pretty you probably can only flex them 1 or 2 times and then they'll snap, so you got to be careful. I just want to mount this somehow so it doesn't flop around and these wires won't break. And also you can see here I put in the 1.2K resistor. This actually is 1220 ohms measured, so that's I had lots of 2 watts, so I threw one in. Why not, eh? And mounted the board back in. Make sure you check all these connections because you're flexing this board back and forth. And these wires here are solid conductors and they will snap. So make sure that they're all still good and none of them have broken. Otherwise you'll have a drop channel. And the power wires are good. And just reinstall everything. And I'm going to get some silicone and mount this relay down. Just on the board, I think, like that. And that'll be the end of it. And now you just take it and test it. You're going to have to realize that depending on what kind of relay you get, you're going to have to measure its coil resistance and you're going to have to adjust this resistor accordingly. They had higher sensitivity relays than this one. This was just a standard and it had a 2.5K coil resistance. And you have to adjust this resistor because if you let too much current flow through that coil, try and imagine how tiny that little coil is inside this relay. And it can only dissipate so much heat. I think the maximum on the data sheet was something like 100 milliwatts or something like that. And if you go over that specification, you can burn out that coil inside there. So you're going to have to remember that. And well, your data sheet's your best friend, right? Whatever relay you decide to get, pull a data sheet for it and be very up on what it says. And like I said, I didn't get the one with the internal diode because there's one external. I could have got one with an internal diode and just removed this external diode. That would have been my choice. But I decided to go and stay with one that had no diode built in. So the only thing to do now is I need to mount this down with adhesive and then put the cover back on and we're going to do a test. So I think that's what we're going to do next here. I don't know if there's anything else I need to mention. I think that's it. It should work now. It should work without dropping out any channels. Alright, so all we need to do now is do a final test on this preamplifier. I got the Harman Kardon PA2100 signature series, and this one is just going to be used as, I gotta wake it up here. It has a sleep function. That's when you turn it on, it lights the orange. It's in a sleep, and you have to feed it a signal to wake it up. So the amplifier is alive, it's on. So let's turn this up about 20%. Let's turn on the power. Should be a delay for the relay. And there we go. And we got both channels. Sounds clean. It's working. So I'm going to wrap this up. I hope you found this useful in the if you have one of these 725s preamplifiers. I think that's going to be a necessary modification you're going to need to do, if not now or sometime in the near future, because you know, the old relay, where did it go? I don't have it here. The old relay is aged and you know, it's corroded and needs to be replaced. You can try cleaning them. You might get a little bit of more life out of it, but eventually it's going to need to be changed out. So once again, thanks for watching. Hope you enjoyed, and we'll see you on the next one. Take care.